Hello, good morning or good afternoon, everyone. I'm David Sauvé, and I'm Stantec's Innovation Leader for our Global Infrastructure Practice. Really appreciate you joining us today for Stantec's Infrastructure Innovation Webinar Series, which we kicked off earlier this year. We're super excited about today's webinar. We have our tunneling and transportation engineering experts, and they're going to discuss an installation method that was used to install a structure below railroad tracks in a single weekend, which is an amazing accomplishment. This innovative method is called lateral structure jacking in an open cut, and Stantec is one of the first to implement it in the US on a railroad project. During today's webinar, we're going to compare this method with other modern tunnel installation techniques and show you just how we did it on the Long Island Railroad project. I'm going to turn it over in a second to Bob Pinheiro, who's Vice President of Transportation Infrastructure Engineering here at Stantec. Before I do, I just want to remind everyone to type any questions into the question box throughout the presentation, and we'll answer them at the end. I will now turn things over to Bob. Hope everybody enjoys.
Okay, thank you, Dave, and good afternoon, everyone. And again, welcome to the webinar. We're really excited about this. We've been working on this project for the last 4 years. We're into the final year, and as David said, we really want to talk today about how we got rid of a bunch of the grade crossings at the project by laterally jacking in the new bridges that would support the railroad and allow the vehicles to pass underneath. We're going to start off, though, with just a little discussion on other modern tunnel installation methods. You'll hear from Anil on that. And then Pak will talk about the third track project in general, and then go through how we actually have designed and jacked these bridges into place. And at the very end, we have a chart that is a comparison of all the methods that you're going to hear about and the risks, and on how they rank as, minimal risk to substantial risk as you move forward in the project. And at the end, then we will have a Q&A for anyone who has any questions. Just a little bit about the speakers. Again, I'm Bob Pinheiro. I'm Vice President in the Transportation Group here at Stantec. And for the last 4 years, I've been the design coordinator for the Long Island Railroad third track design build project. We're replacing 8 grade crossings, 8 other bridges, completely rebuilding 5 stations. There's close to like 9 miles of retaining wall and sound walls on the projects, several new parking structures, and then the addition of the actual third track and all the systems that go along with that. So it's been a very involved project, a very interesting project, and we're very proud of that. We're only a year to go, and most of the work is done. A lot of the systems work is being done right now. It was very entertaining for me to be on this project because this is kind of the industry that I've been working in for the last 35 years, is in the transit realm. After I'm done, you'll hear from Anil Dean. Dean is got over 25 years of tunnel experience. He's one of Stantec's tunnel practice leaders, and he's been involved in a number of innovative projects with tunneling underneath roadways or rails. And finally, Pak, you will hear from at the end. Pak has got over 22 years of bridge experience. I know Pak well I've probably known Pak for most of those 22 years that he's had experience working. Pak has been a member of the third track project since its beginning, and has really led the design of a lot of these undergrade crossings, elimination structures that you'll be hearing about. And he also worked closely with the contractor as we were getting ready to do this work to make sure that we had everything set up so that we could shut the railroad down, get the bridge in place, and open the railroad back up again in just 3 days. So with that, I'm going to turn it over to Anil.
Great, thanks, Bob. So I wanted to touch on some other modern tunnel installation methods and other ways grade crossings, could be constructed prior to, getting into lateral structure jacking and talking about all the advantages of the lateral structure jacking method for rail, undercrossings and other short right-of-way undercrossings. So the first method I wanted to touch on here is cut and cover. I mean, this is the traditional way to install an undercrossing. There are two flavors of cut and cover shown on this slide. On the left side, there's what's called bottom-up cut and cover, which is very conventional. The excavation starts from the ground surface. It proceeds down while it's being shored, and there's a base slab, and then the structure, which is not shown on the slide, would be built inside the excavation and backfilled. The other flavor of cut and cover is what's called top-down cut and cover, and this involves starting with some shoring, excavating a deck and placing some decking above the shoring so that the roadway or whatever is at grade can continue to function, and then excavating down underneath the deck to complete the excavation and then build the structure within the excavation. So just another illustration of cut and cover is on the next slide. We will kind of start a little animation. So this animation shows just a pedestrian tunnel that was designed with traditional cut and cover methods to go under a roadway. And this just walks through basically the tunnel itself and then comes out the other side. So it was a nice animation just to illustrate to the clients and stakeholders what this cut and cover installation was going to look like after it was completed. So post, post construction. But the design was with, traditional cut and cover methods. So that's just an illustration of what, what it looks like. On the next slide, we have a tunnel boring machine. So this is another way, again, to install big tunnels. This slide is from the LA Metro's Crenshaw LAX project, where we helped LA Metro with a lot of construction management assistance. So the TBM shown on the right there is nearly 22 feet in diameter, and TBMs are available for all types of ground conditions. LA happens to have some challenging ground. There's naturally occurring hydrocarbons in the ground. Of course, oil wells, are still pumping in the LA area. And it's largely in soil, but TBMs are available for rock as well, and there are pressurized face TBMs and open face TBMs. This is a pressurized face TBM we're looking at. It's a earth pressure balance, or EPB, tunnel boring machine. There are other types like slurry, which would use a pressurized fluid to excavate the ground, but this particular machine uses what's called earth pressure balance. So that's just a brief slide on TBMs. And then what I wanted to go into next is another type of tunneling that we use and design quite a bit, which is called sequential excavation, or SEM. Let's see. So this slide shows our project in Vermont for VTrans, the Vermont Department of Transportation. And this is during construction, and I wanted to go through a few slides showing what what the process was. But basically, sequential excavation methods are a stepwise method of tunnel mining. So we could advance a few feet at a time, support the ground, and then move forward again. So it's a fairly complex sequence, but once there are contractors that specialize in this, and once you get the hang of it in the ground, it's fairly easy and quick. Now, the advantage is that it's field adjustable to suit ground conditions as they change along the alignment. So just going through some of this, if the next slide shows the geotechnical profile, which is, cross section of these two highway embankments in Vermont. And we had two SEM tunnels, one under the southbound embankment and one under the northbound embankment through, different ground conditions. There was a marine silty sand and a marine silt that came in underneath the embankment materials, but these were fairly deep embankments. So the advantage here was being able to tunnel underneath them while the highway could continue in operation while the work was going on underneath. So nobody really knew, obviously driving on the road, that 30 feet under them there was an active tunnel operation going on. And the next slide shows, the start of one of the shored excavations for the launch pit of the SEM, of one of the two SEM tunnels. And what was nice about this method also is that the contractor was able to handle the water very effectively. The water table wasn't very high, but these are vacuum dewatering lances essentially, which are pushed into the ground and were used very effectively to dewater. And that helped stabilize the ground to enable the initial push of the excavation. And the next slide shows installing tunnel support. So this is one of the design drawings, and it shows a stepwise construction. In the orange, it would be, for example, the first step, and then pre-support is installed with red spiling, and then there are girders, what are called lattice girders, installed in blue. So after the first step, the tunnel heading may progress a couple of rounds on the top, and then the bench would follow. And so I wanted to show a couple of photos of that in the next couple of slides. This slide shows the heading excavation and installation of those lattice girders for pre-support. And the lattice girders are basically rebar and steel bars that have been formed to efficiently transfer load to the initial tunnel support and then ultimately to the final support. But this was a very clean operation, moving stepwise forward through the launch shaft shoring. After some of the initial top heading was advanced, this shows the bench excavation with some of the mucking equipment that the contractor used. And then as we keep going, the contractor would install welded wire fabric within the lattice girders, so they're getting ready to shotcrete and provide initial tunnel support. But the ground is very stable because of the pre-support that's already been provided. Once the initial support is in, then the final support goes in with some cast in place concrete walls shown under this arch, and the precast concrete arch was rolled into the excavation in segments. They needed to put a much larger culvert underneath these highways. They had culverts that were deteriorating and undersized, and so this was partly, to facilitate drainage around the embankments and also to meet environmental requirements, and had a lot of other advantages for VTrans. So that set of slides illustrates the SEM method. The next method here is box jacking. So it's similar in a lot of ways to the lateral bridge jacking that Pak's going to talk about in a minute. But this is a mining method, so it allows for mining simultaneously to the jacking operation. So the boxes, and we can see in the photos on the top right, these projects are both in the UK, but there are large boxes shown that were cast in place in excavations, and then as mining proceeds, the boxes are jacked into place under the highway in the case of the left photo. The bottom left sketch or diagram kind of shows a cross section of how this works, and there are anti-drag systems or ADS used to mitigate friction between the box and the ground. So it's a very innovative method as well, but it is a mining method, so it involves some tunnel related risks, and there are usually extensive ground improvement required in soil. So and Pak will compare and contrast these methods later in the presentation. But before we go to lateral bridge jacking, this is the last tunneling method I wanted to touch on here for conventional tunneling, and it's called pipe roof tunneling, which involves installation of steel pipes, which are shown in the image towards the top of the screen. And this project was in the Toronto area for Metrolinx under the Highway 401, 409 interchange, which is the busiest interchange in North America. But we were fortunate enough to have been selected by Metrolinx to be their engineer for this, and the project subsequently was completed under an APD, alternative project delivery arrangement, with a contractor. But the construction involved the pre-support using these steel pipes at the top of the tunnel, and then the contractor essentially proceeded with a sequential excavation method, or SEM, beneath the steel pipe pre-support. And what we're seeing in the main image is shotcrete lining, which is the initial support of one of the twin rail tunnels. And the other pictures show just the pre-support installation and geometry. But it was a fascinating project to work on and successfully completed. So with that, I wanted to hand it over to Pak, who's going to focus the remainder of the presentation on lateral bridge jacking methods and the LIRR expansion project. Pak?
Thank you very much, Anil. Hello, everyone. I'm Pak So. I was the structural design lead for many of the bridges used for the grade crossing eliminations. I'm going to begin my part of the presentation today by giving you a broad overview of the LIRR expansion project, which is also known as the Third Track Project. So the main objective of this mega project was to add a third track to a 9.8 mile main line segment between Floral Park and Hicksville. That's out in Long Island, New York. So previously, this 9.8 mile segment only had 2 tracks. So as you can imagine, adding a third track would significantly improve operations for LIRR and reduce delays for the traveling public. So obviously, to add in this extra track, there was massive infrastructure work that went along with that. We retrofitted 8 existing railroad bridges that only held 2 tracks. We had to widen them to hold 3. We built 6 new railroad bridges, as well as 5 new vehicular bridges. So besides bridges, which is my specialty, Stantec and 3TC, we also did a significant upgrade to many of the existing stations, many miles of retaining walls, sound walls, track work, signal systems. And with all this work, you can imagine there was a massive utility relocation operation that went along with that. I'm proud to say we eliminated 8 of those dangerous grade crossings that Bob mentioned before. And finally, the bulk of my presentation will be to discuss this innovative accelerated construction technique that we developed along with 3TC to significantly reduce track outages. So during the proposal phase for this mega project, everyone, as far as we knew, we're proposing to use temporary track support structures along with various other accelerated bridge construction methods like bridge roll-in operations. Well, we really sharpened our pencils and worked very closely with the contractor and submitted this method that I'm going to go into as an alternative technical concept to see how the railroad would feel about it. They really, really loved it. That it resulted in a lot less track outages, and it really was one of the main things which helped Stantec and 3TC win this mega project. Okay, so first let me discuss the typical bridge structure that we use for the grade crossing eliminations. So the bridge structures that we came up with, they're comprised of a U-shaped substructure where the abutment stems are supported by a common invert slab or a base slab. So typically for a bridge structure, you have 2 abutments that are supported by its own footing. Well, we modified the structure to work better with the installation method. Imagine if you're pushing this bridge and it has two separate abutments, you really run the risk of the structure racking around as it's getting pushed. So really combining the two stems of the common slab, it really made a lot of sense and went very well with this method. As far as the bridge superstructure was concerned, we went with steel through girders, which the railroad's really comfortable with. They have them for all their bridges. And really that structure type helps minimize structural depth as well. So that was very suitable. On this project, we installed 5 single span bridges, and we did have 1 2-span railroad bridge that you see here in the photo. Okay, so at this point, you might be scratching your heads thinking, I thought this presentation was about tunnels. Why are we talking about bridges? Well, this slide here shows a schematic of a tunnel structure, which we're actually coordinating right now with Long Island Railroad to install using the same methods as how we installed the bridges on the third track project. This tunnel is planned to be laterally jacked into place in an open cut, just like the third track bridges I showed you before. So if you get nothing else from the slide, please understand that whether it's a bridge structure or a tunnel structure, you can use this lateral structure jacking method and the open cut all the same. So some of the key benefits of this structure jacking method in an open cut. As mentioned before, it's the method we use to build all the new grade crossing elimination bridges on the third track. The real beauty of this method is you get to build the entire structure adjacent to the final location without significantly impacting LIRR operations. The significant impact to the railroad is really limited to 1 full weekend outage. An open cut and installation in the same weekend means significantly low risk to the tracks. If you think about it, you're ripping up the dirt and you take out the tracks, you take out the dirt, you build your structure, put the dirt back and put the tracks back in 1 weekend before the trains are back on it. There's really no track risk. So additional key benefits. As I mentioned before, during the proposal phase, many of our competitors were proposing to use temporary track support structures. Well, this photo on the left shows a temporary track support structure in a brace excavation. It's actually a photo from an old project we did where the objective was to build bridge abutments underneath the train tracks while they were running over these temporary track support structures. Well, in order to install the sheeting and the bracing and the temporary track support structure that you see here in the photo, that really means a slew of additional single track weekend outages. So the method that we use, we don't need all these additional track outages and all this material even. So really it reduces construction time and saves material. The jacking operation is very quick and accurate. On the third track project, the structures that were jacked laterally were not off more than 1/4 of an inch, which is pretty amazing. So now I talked about some of the key benefits. I'd like to get into some of the challenges of this method. So jacking a structure in laterally, typically you want to do that in a wide open space. Picture train tracks in a wide open field. On the third track project, we proved that this can be done in tight urban spaces. So you can see in this photo up here in the top left corner is a house. At all these sites, we had homes and businesses very close by. This method is good for, really good for sandy and granular soils, not really ideal if the soils are mainly clay. And finally, because of the fact that we have to finish all the work in 1 weekend, that introduces a time risk that some of the other methods that Anil talked about before do not have. The work must be completed in the weekend to allow trains to run for the Monday AM rush hour. So now I'm going to walk you through a step-by-step illustration of just how we laterally jacked in our bridges. In this schematic, the top of the slide has a plan view of a typical grade crossing, and the bottom is a longitudinal section that goes along with the plan view to help you understand the steps. So this is a typical dangerous grade crossing where the road and the tracks cross at the same elevation. You can see the crossing gates here and here. So before I begin, let me preface this part of the presentation first by clarifying a few things. The goal at the end of this method is to have a new railroad bridge structure that supports the tracks over a new depressed roadway that's going to go under our new bridge and back over. There is typically a new roadway bridge at many of our sites. In this schematic, it's going to happen to be on the right side over here. While we did not disturb the tracks for a significant amount of time, at all these sites with the MPT plan, the roadways were typically closed for a long duration to allow for our construction method. Okay, so with all that said, let me start. So the first step that has to happen is sheeting has to be installed parallel to the tracks that you see here, that red sheeting. Also at this time, we will install jacking box sheeting in orange, as well as some permanent steel sheeting that was used for the roadway bridge. With sheeting installed, the next step is then to install supportive excavation piles that you see in blue. That's supportive excavation for the jacking pit that's going to be here, as well as for the post and panel walls along the roadway. Also, these green circles are roadway bridge piles that get installed at this stage. So with the supportive excavation system installed, the next step is to excavate all this soil that you see here in the pink color. It's important to note that as the contractor digs down, they also had to install a series of lateral steel ties that held these two lines of sheeting in place. As you imagine, once they get down to the bottom, the cantilever distance here is pretty tall, so the steel ties really help in order to keep everything stable so the trains are running while all this work is going on. And there's the excavation. In the red dashed lines are those lateral steel ties that I mentioned before. So now with that pit dug out, the contractor then comes in and installs a jacking block and a jacking slab that you see here in cyan. This jacking slab is ultimately what the proposed structure is going to get pushed on. So it's very imperative that it's installed very level, very flat, and free of dips and bumps. If there's not good quality control, and imagine if you have bumps in that slab, imagine trying to push a structure over that. It will really complicate things. So after the jacking slab and block are built, the next thing is the contractor builds that U-shaped substructure that I showed you photos of before. With the bridge substructure built on top, the contractor comes in and then sets and builds the railroad through girder bridge. And all this work is done without any weekend outages. So the trains are running and now you have a completely built structure right next to it. As I mentioned, without significantly impacting the railroad. So now that the bridge structure is built, we're ready for our weekend outage. So the full track weekend outage is a 53-hour track outage. It starts with the railroad removing a portion of the tracks in this area, and then the contractor coming in and doing a mass excavation. The contractor also has to remove portions of the sheeting that you see there and there, because those portions of the sheeting would get in the way as this structure is going to get pushed across. So with the soil excavated and that sheeting taken out, we're now ready for our jacking operation. So the bridge is pushed using a series of hydraulic jacks and spacers that gets the load back to that jacking block. The rate of the push is around 6.5 feet an hour. And at the end of it, the bridge is pushed into its final location. I want to note that these pushes, again, were all very accurate and fast and really without significant issue. Again, within a 1/4 inch tolerance, which is pretty amazing. So after the bridge is pushed into place, the contractor then has to do a backfill operation. Since these are bridge structures, they also have to install these approach slabs that you see here in blue. After the approach slabs are installed, the next step is there's some final ballasting, and the railroad puts back the tracks. They conclude the weekend outage by running test trains and then putting the tracks back in service before Monday AM rush hour. And that's basically how we did all of these grade crossing eliminations. So I just want to note that we did 6 of these bridge jacking operations, and all 6 were pushed and completed always ahead of schedule. There were no delays, and train service had always resumed on time for the Monday AM rush hour. So next up, we're going to show a video that the railroad put together. This is our first bridge push site.
I have a better appreciation for the work that they do.
It's another proud day for Long Island Railroad. It's another proud day for the third track mainline expansion project.
We're roughly 4 hours ahead of where we're hoping to be at this point. A lot of planning, a lot of thought going into how this is going to be done, and the contractor really outperformed.
It's one thing for us to have these meetings at town hall and even on site and to talk about what's going to happen and what's happening, but to actually see it in motion, to see the dedication of the workers that were out there all day long. It was a really hot day that day.
Here we are at Urban Avenue in Westbury, and it's the first of 7 grade crossing eliminations that I'm proud to say is on schedule. The weekend work is on schedule, the project is on schedule, and this whole grade crossing elimination is one of the key components of the project.
Already, because there's no grade crossing here for cars to cross, the trains don't have to hit their horns when they come by here, so it's already quieter. The accidents will be gone. The trucks won't hit the bridges anymore. We won't lose lives like we did in Mineola. Add to that, traffic is going to move quicker. We've got 45% more capacity to run trains once this is all over. It's going to be a huge change, both locally and essentially globally for Long Island.
We've had 200 guys here. I call it dancing among each other, interacting. The machines, the equipment's been moving in and out. It's been working like clockwork.
I think it's phenomenal. On Long Island, we rely on the Long Island Railroad to get back and forth either to the East End or going west to New York City.
New infrastructure here that supports the local community, supports Long Island.
That is the future of Long Island Railroad. We are a major part of making Long Island Railroad and Long Island successful.
Hope you all enjoyed that movie from the Long Island Railroad. So we put together a matrix to compare the methods that we discussed today: cut and cover, tunnel boring machine, sequential excavation method, box jacking, pipe roof, and finally lateral structure jacking and open cut. It wasn't stated earlier, but this matrix is really put together keeping in mind that these are really for shorter tunnels, say no longer than 100 feet, right? Then we sprinkled across in the chart various risks and issues that we thought were relevant. So industry experience, ability to handle ground conditions, construction period, track closure, weekend time risk, settlement issues, construction staging areas, and relative construction costs. And then we gave an overall assessment. So you'll see this chart has green, orange, and red dots. A green dot means good for the risk or the particular issue. Red is the riskiest or not desirable for a certain issue. And of course, orange is somewhere in between. So let's just look at the cut and cover as an example. Of course, it's green for industry experience. It's tried and true, and everyone knows how to do it. Ability to handle ground conditions, that's really not an issue because you're opening the ground and building something and then putting it back. Construction period and track closure would be red because you would be taking that track out of service for a long duration of time. There's really no weekend time risk, so that's a green dot. No settlement issues for similar reasoning to the ground conditions. Construction staging area would be a green dot. Relative construction costs we put as orange. And because of the amount of time you're taking that track out, we gave it a red for overall assessment. So looking at some of these other methods and focusing on the red dots for the TBM, you need a big construction staging area to build that machine. And of course, the relative construction cost is very high. For sequential excavation method, you have potential settlement issues, as well as a high relative construction cost. Box jacking, you have similar, if not worse, settlement issues, and same high relative construction costs. Box jacking, we gave a red. And then pipe roof, there are no red dots, but most of the issues we feel have orange dots. And then finally, we get to the lateral structure jacking and the open cut. So industry experience, we gave an orange dot to this. Again, well, we got a company from Italy to come manage the lateral push. We don't think it's a red because we are dealing with hydraulic jacks after all, which is not a new technology. The ability to handle ground conditions, it's a green dot because again, you're doing everything in that weekend, you're opening up and putting it back in. The construction period is a green dot. So here under track closure, we put an orange dot because you are disturbing the railroad for a weekend. Then there's that weekend time risk that I talked about before. Here I put it as an orange dot, but I do want to stress very importantly, work has to be planned to fit in a weekend outage very carefully. You have to carefully plan with the railroad, with the contractor, and if it's just too much work, this orange dot can easily become a red dot. So in the third track project, the railroad wanted a guarantee. They loved the method that we presented them, but they wanted a guarantee that the work would be done on time, and even requested a schedule from the contractor that was down to the 15-minute interval. So, and not your typical hourly interval. So again, settlement issues, just like ground conditions, are not really a problem with this method. The staging area isn't too bad, so we gave that a green dot. Relative construction costs, we also gave that a green dot. So here we gave it an overall assessment of green. Okay, so at this point, I'd like to summarize the presentation. Today, Bob, Anil, and myself, we discuss with you modern tunnel installation methods, namely cut and cover, tunnel boring machine, sequential excavation method, box jacking, and pipe roof. We also showed you, hopefully show you how we successfully worked very closely with the Long Island Railroad and 3TC, the contractor, to use this very innovative lateral structure jacking in an open cut method on the third track project, which resulted in a significant reduction of track outages. We also compared the risks associated with the various methods, and we showed that this lateral structure jacking and open cut is a very viable, low risk, cost effective installation method, of course, provided that the conditions on your project make sense for it. So at this point, I'd like to turn it over to the floor for any questions. If we don't get to all the questions today, my contact information is up on this slide. We also have a web link here for our tunneling services. And as a reminder, feel free to type your questions into the chat box. Thank you for listening.
Thanks, Doc. Excellent presentation. Okay, I have a question coming in right now. I'll read it. How was the jacking controlled to ensure the structure ended on the intended alignment?
I can answer that question, Jenna. So there was always survey going on while the structure is being jacked. And basically, as you can imagine, let's say there's these targets on the structure, and let's say one of the targets on one side is advancing a little too much ahead of the other side. They can control the jack, so you can jack the other half of the bridge a little bit more to get it back on alignment. So it was always done with careful survey to make sure it's in the right place, it doesn't drift. As far as vertical elevations are concerned, I did mention briefly in one of the slides that this method has a built-in way to correct elevations. So the leading edge of the structure has a slight taper to it. They call that a sled. It's really just a taper, and what happens is that as they're surveying the structure, if they're noticing that it's riding up too high, there's an excavator inside the structure. What they just do is they just simply dig out a little bit more soil than they were intending to, which will let the structure kind of glide back down. If they're noticing that the structure is starting to go down a little bit too low, what they do is they just mound a lot of soil up in front of that leading edge, and that will allow it to kind of like glide up on that mound of soil. So they controlled elevations this way, and it actually worked really well.
Great, thank you. Okay, next question. How long did it take to design and construct a typical undergrade elimination site on the third track project?
Okay, so that site, Urban, that I showed you the video of, the design and coordination with the railroad on that, I recall, took approximately like 11 months. Then, you had a few months before the construction took place, and that typically took 12 to 14 months. So, that includes all the time to make the jacking pit, do all that excavation ahead of time, the sheeting, and then ultimately the push, and even the construction after the push, which is the rest of that depressed roadway.
Great, thank you. We do have another question. Were there any challenges encountered during the lateral jacking operations?
Okay, I can answer that again. So the pushes, they went really well without any major problems really. At one of the sites, so again, the contractor has to construct this bridge structure on top of that jacking slab. So they typically put a bond breaker to make sure when they cast the concrete that it's not going to stick to the jacking slab. So there was actually a small portion of bond breaker that either got ripped off by mistake or wasn't put in. So during one of the pushes, there was a slight piece of concrete that ripped off, but it really, it's nothing that couldn't be repaired. But I think that was the biggest problem that I remembered, which isn't really too bad.
Nice. Okay, I have one more question here. Can you describe how elevations are corrected for as the structure is pushed?
Oh, I think I answered that in with the first question.
Okay.
Yeah, with that tapered edge and basically putting more soil in front to let it ride up, or taking more soil in front to let it glide downward.
Okay. Oh, I do have one more question that just came in. You mentioned that the lateral structure jacking method is not suited to clay ground, but what about rocky ground, as piling is not feasible through very coarse material? Also, how did you tie the sheets under the trap?
Okay, so the first part of that question, I would think that as long as you can easily excavate the material out, without, so when you say rock, I envision, like heavy rock. But if it's something that is granular or can easily be excavated, I would think this method makes sense, or would have to be looked at carefully. It works great with sandy soils, which is what Long Island has all over the place. I'm sorry, Jenna, what was the second part of that question about how the sheets are tied together?
How did you tie the sheets under the tracks?
Okay, so the contractor we designed, and the contractor installed a steel rod. Basically, you laterally drill them through, and when they get to the other side, you just attach that to the sheeting that's on the other side.
Great, thank you. Okay, the track be handed back at normal speed, and also, what was the form of the run on slabs?
Can you say that question again, Jenna?
Sure, so it's a two-part question, I guess. The first part, could the track be handed back at normal speed?
Okay, so for all the undergrade crossings, yes, when they resume train traffic, there was no reduction in speed. There was actually one existing bridge modification site. That's not what was installed with this push, but there was one bridge modification where we had to start off at a reduced train speed, and that only lasted a few hours. But typically, yes, you would give it back at normal operating speeds.
Okay. What was the form of the run-on slabs? Does that make sense?
I'm not sure I follow that question.
Okay, no problem. I have the contact for the person who asked this question, so we can get in touch with them.
Sure.
Sorry.
No problem.
Yes, but that's all I have for questions right now that have come in. So if no one else has anything, then I think we'll wrap it up. This has been excellent. Thank you so much for your time. Thank you for our thank you to our speakers, and thank you to everyone who joined us today. We'll be sending a follow-up email with the recording of this webinar, as well as contact information, so we can keep the conversation going if anyone has any more questions or comments or ideas. Thank you.
Thank you, everyone.
Thank you.